Okay, we're going to be relating polar and Cartesian coordinates again, and really we're going to be relating polar equations and Cartesian equations, but we need this foundational information here at the top in relating the polar and the Cartesian coordinates in order to go about approaching these problems. So the first set of examples we're going to look at, we're going to talk about replacing polar equations with Cartesian equations, and then we're going to go from Cartesian equations to polar equations. So let's go ahead and take a look. So the first example I have here says r cosine theta equals 12. So I should recognize that from my equations up at the top relating the polars to the Cartesians. And I know that this right here, r cosine theta, is just equivalent to x. All right, it's just equivalent to x because x equals r cosine of theta. All right, so what I'm going to say here then is x equal r cosine theta. Well, that just equals 12. So my equivalent Cartesian equation states that x equals 12. All right, and nothing to it. That's it. All right, now looking at the next one, I see again r cosine theta. All right, let me change color there. R cosine theta. That right there is again x. All right, because x equal r cosine theta. And then I see again this other one over here, r sine theta. And that right there is y, because y equals r sine theta. All right, so what I'm going to do here is I'm going to say, okay, then this is not terribly difficult because this is just 7x plus 2y equals 1. And so here I have my Cartesian equation, 7x plus 2y equals 1. Okay. All right. And then the very last example here, before we look at Cartesian to polar, is this r equal 1 over 9 cosine theta minus 6 sine theta. All right, and this one's not terribly difficult either. What we're going to do is we're going to take this right here and we're going to multiply both sides. We're going to clear the fraction. So I'm going to multiply this by 9 cosine theta minus 6 sine theta. And I'm going to do the same thing over here. All right, so I'm going to put that right in there. So let's take a look and see what that looks like. We're going to have r multiplied by 9 cosine theta minus 6 sine theta. All right, now this has the effect of crossing itself out. So we're going to set this equal to 1. All right, now I have my r that I can distribute. I have 9r cosine theta minus 6r sine theta, and set that equal to 1. Okay, and you should start seeing what's going on here. All right, we have r cosine theta, r sine theta. What does that look like? Well, this right here, remember, x equal r cosine theta and y equal r sine theta. So, very simply put, I have 9x minus 6y equals 1. My Cartesian equation right there. All right, now let's go ahead and take a look at some examples where we replace Cartesian equations with polar equations. Okay, so here in these examples, we're going to take what we know again. So we know, namely here, that x is equal to r cosine theta. Then we know that y is equal to r sine theta. And so we're going to use those facts in order to carry this out. We're going to say 2r cosine theta plus 3r sine theta equal 6. Okay, now we're basically done. I mean, the only other thing I might suggest is to factor out the r, and that will give you 2 cosine theta plus 3 sine theta equals 6. But otherwise, I mean, you're good to go. So we'll box this right here as our answer. All right, and now continuing on, take a look at the very last example here in this video. We're going to say, okay, well, this right here, x equal r cosine theta, I need that. Y equal r sine theta, I need that. And then another x. All right, and so we have all of that down, and now we substitute in what we know. we know that we've got r cosine theta, and then it's going to be square plus r sine theta, and that again is going to be squared, minus 4 times an r cosine of theta. Okay, so that will all equal 0. All right, so let's see here. I'm going to have r squared cosine squared theta plus r squared sine squared theta minus 4r cosine theta. All right, set that equal to 0. I know I'm going to factor out the r squared. I'm starting to see Pythagorean identities here, and I saw it actually right away before I did any of this, but let's go ahead and see what happens. Okay, here we have it. We know that cosine squared plus sine squared, this right here, is equal to 1. So I'm left with r squared minus 4r cosine theta equals 0. So now what I'm going to do is I'm going to factor out an r. Then I'm going to have r minus 4r factored out, and then r minus 4 cosine theta equal to 0. And I can apply the zero factor property, and I can say, well, r equals 0 in one case, and in the other case, r equals 4 cosine theta. And this is actually going to be our answer. All right, when you think about this one right here, this one right here is just a point, which is the origin. This is a circle of radius 0. So basically, it's just a point. All right, the origin. All right, but we want an actual polar equation that will give us some value. And so we have this right here, r equal 4 cosine theta. All right, and there's really nothing to it. All right, so as always, I hope this video was helpful. And remember, like and subscribe.